Welcome. This lesson is from page 191 in your book, Solving Inequalities by Multiplication or Division. Truthfully, the lesson itself isn't hard, but there are a couple of little things that could throw you off or make your answer wrong if you don't remember the little details. So let's go through this together. The objective is that you'll be able to solve equations with the multiplication and division properties of inequalities. And then the key part for your essential question is, why would you need to flip the inequality sign when you multiply or divide by a negative number? So first of all, let's start with the positives. And so please copy the blue and the red in your notes. That says when multiplying or dividing by a positive number, if A is greater than B when you begin, then if you just multiply C by both sides, the left will still stay greater than. Same thing over here. If you start out with A being greater than B, then if you divide C by both sides, the left still is greater. If A is less than B and you multiply both sides by C, the left is still less than. And here if you divide C by both sides, it doesn't change the inequality at all. All right, so our first example in the book, you will just see A divided by 2 is less than 32. And you need to solve what is A. So first you ask yourself, if right now A is being divided by 2, to solve it, I do the inverse, which would be multiplied. And so if you multiply 2 over 1 times A divided by 2, the 2's, let me see if I can get this, the 2's cross themselves out. And so you get just A. But if you multiply the left side of the inequality by 2, you have to also multiply the right side of the inequality by 2. And 32 times 2 is 64. And because they were both positive, or the number you were multiplying was positive, then the inequality does not change. A is still on the left and less than 64. Then simply to graph it, you just make a number line in your book. And this is what your homework will be asking of you also, is to make the number line. And you would have an open circle at 64, and it's less than 64. So A can be anything less than 64. Now in just a couple of slides, I'll be showing you a greater than, less than or equal to, and if there's that little equal to sign underneath, then you'll have a closed circle. But if it's just greater than or less than, you'll have the open circle. All right, so here, same thing. A divided by 4 is greater than negative 16. We want to get rid of the 4. We want A to be alone. So we would ask ourselves, what's happening to A is being divided by 4. So to get to get A alone and get rid of 4, you'd multiply 4 over 1. The 4's would cross out. If you multiply this side times 4, then you'd have negative 16 times 4. And the inequality does not change because we aren't multiplying by a negative number. Yes, one side of the inequality is a negative. That just tells us a negative times a positive is a negative answer. But because the 4 itself was positive, the inequality does not change. So to show you the number line, you would create in your notes, make sure your negative numbers go from least to greatest. You'd have negative 65, negative 64, negative 63. Because it's just greater than and not or equal to, just because it's just greater than, you would have an open circle and then greater than sign. The arrow pointing toward the greater than. All right, here is the example I was leaning toward. Because we have this less than or equal to, we will need to change the inequality when we get down here. So it's up to you if you want to listen to the whole example and then pause and write this down. But this needs to be in your notes. If the inequality is greater than or equal to, or less than or equal to, then the dot on the number line is closed. Whoops, just had a mind of its own. All right, so let's finish this problem. Right now, A is being divided by 3, so to get A alone, you do the inverse of division and multiply. Oops. 3 over 1 multiplied by A over 3. The 3's cross themselves out, and now we have just A. Oops, let's not get ahead of myself. Okay, negative 25. If you multiply this side times 3, you have to multiply this side times 3. And so let's move this, and you'll see it's still less than or equal to. And then because we had a negative times a positive, the answer is negative. And so to graph it is a closed circle, and A is less than negative 75, so your arrow would go to the left. If you haven't written the words down, please pause and write down that information. You'll need that in your homework. All right, so now we have the opposite. We have a variable being multiplied by a number. So in your book, you would just see 4A is greater than or equal to 28. So you tell yourself, oh, right now the variable is being multiplied times 4. We want to get the variable alone, so divide by 4. If we divide the left by 4, we have to divide the right by 4. Now we get A alone. And so you would say A is greater than or equal to 28 divided by 4 is 7. Here's the number line. Notice it's a closed circle because it's or equal to. Oops. Excuse that. I'm videotaping at school this time, and that was just the dismissal bell. Moving on. Now, this is the opposite. You do need to pause and write this down. When multiplying or dividing by a negative number, that means when the number you multiply on both sides is negative, not necessarily if one of the answers is negative, then you flip the inequality. Notice it started out with A greater than B, but in your final answer, you'll flip it to have the less than sign. The negative number just changes the direction of the arrow on the number line, so you need to flip the inequality. Then, when multiplying or dividing a negative number, if A is less than B and the number you're multiplying both sides by is negative, then you flip the inequality. And so where it started out as a less than, it's now a greater than, because you're changing the direction of the arrow on the number line by multiplying it by a negative number. Just a heads up, last year kids would think that if the original answer was negative, if just one of the numbers was negative, then that changed the sign. No, it's only if the number you're multiplying or dividing both sides by is negative. We'll practice that. All right, so a couple more quick examples. I think I'll try to speed up here a little bit. So, like we did before, A divided by negative 5, you want to get A alone, multiply times negative 5 over 1. If you multiply, sorry, I'm jumping ahead of myself. So that crosses out the 5's. If you multiply the left times negative 5, you multiply the right times negative 5. Here is where let's go a little slower. Positive times a negative is a negative answer, but because the number I multiplied by both sides is negative, we flip the inequality. Don't forget that. Then that means A is greater than negative 75. Well, that's kind of hard to see. Greater than negative 75, but not equal to, so it's an open circle. All right, same thing. A divided by negative 3, you say what's happening to A? It's being divided by a number, and so you have to multiply, do the inverse operation. The negative 3's cross out. Now we have A alone. If I multiply the left times negative 3, I need to multiply the right times negative 3. And so a positive times a negative is a negative answer, but I multiplied both sides by a negative, so I have to flip the inequality. Notice this is less than or equal to, and so it's a closed circle and to the left. So even the concept isn't that hard by itself, but there's a lot to remember. Open circle, closed circle, flip the inequality when multiplying or dividing by a negative. Here we have a negative 12 times x. We want to get the x alone, so we have to divide by negative 12. Now this becomes a 1, so we have just x alone. If we divide this side by negative 12, we have to divide the right by negative 12. And notice here, a negative times divided by a negative is a positive, but because the number that we divided both sides by was negative, we had to flip the inequality. And so x is less than or equal to 5. So a closed circle, flip the inequality, negative divided by a negative is a positive. A lot to remember. I know our time's almost running out. I'm going to try to hurry here. This is just a quick one, but I'm not going to do many more examples. Just to keep in mind, there are some problems in the book where actually the variables on the right-hand side, I'm not going to do any more examples because of time, but if you have the variable on the right, remember you have to think of it as 9 is greater than any other answer. And so you have to flip the arrow to say actually it's a less than because the variable is less than the number given just because the variable's on the right. We'll practice those in class, but I didn't want you to be caught off guard. That's it for today. Have a great night and keep up the great work.